Okay guys, so I'm going to go over your study guide. On here you have all the types of questions you can expect to see on the exam. I included 2 of each one. I'm going to go through and do all of the odd questions, and those are the only ones that you need to do. Well, there's an exception to that. You can just follow what it says on the Google Classroom post. But for the most part, I'm going to do all the odd problems. You can do all the even ones. If you want to, you can do some more for some extra credit if you want to do the evens. You don't have to. You can just do the ones that I'm doing on the video. Okay, so let's go ahead and begin. Question number 1. We're going to talk about multiplication. So let's do that. I'm going to be doing this at lunchtime, so it might be a little bit noisy. I'm holding the mic close to my mouth, though, so hopefully you guys can hear mostly me. Anyway, so how do you multiply? The first thing you're going to do is you're going to look for some shortcuts. Hey, Joel. So for this shortcut, we square the first, we square the last, we multiply these two together and double it. And there's that one. And the next thing you do is the other shortcut. That's a difference of squares. So you square the first term, square the last term, and you connect them with a minus. After you do your shortcuts, you do any sort of box multiplication, which would be these two, or foiling, or whatever you want to call it. So we have x to the 4th, 4x to the 3rd, hey Brandy, and then 4x squared, negative 9x squared, negative 36x, and negative 36. Combine all your like terms, starting with the highest power. X squared and x squared, these two can combine together to make negative 5. Oh, you know what? I don't want to put that one there yet, though. We want to put the next highest power, which is a third power, 4x cubed. And then I'll do the squares. Negative 9 and positive 4 makes negative 5x squared. And then we have negative 36x, followed by a negative 36. The last thing you do after you do the box is you do some distribution if you want to. Well, not if you want to. Kind of need to. All right. So we end up with negative 3x to the 5th minus 12x to the 4th plus 15x cubed plus 90 plus 18, 108. So 108x squared plus 108x. So there's one type of problem you guys need to do, is know how to multiply your polynomials together. All right. Next one. Talk about some long division. Okay. So number 3. Okay, so when you do long division, you got to make sure that you have all your terms accounted for. Notice that we have a 4th power, a 3rd power, and a 1st power. So we're missing the x squared, and when that happens, you need to put a 0 in its place. So this is your setup for this particular problem. Notice the 0x squared that I put in there. And I'll go ahead and work it out. I need this term to be divided into that term. So what would I multiply this by to get that? That would be 5x squared. And we're going to multiply that by all 3 of these. 5x squared times 3x squared will give me 15x to the 4th. 5x squared times negative x will be negative 5x cubed. And 5x squared times negative 4 will be negative 20x squared. And we go through and we subtract all those, which is going to change their signs. So that cancels. Okay. And then we're going to repeat the process. So now we want to find out how many times what would I multiply this by to get this? And that would be negative 8x. Multiply the negative 8x by all three of these. Put your answer down here. Change all the signs. And combine. And this should be our last run through of the problem. So what would I multiply 3x squared by to get 12x squared? And that would be 4. Multiply that by all three of these and put it down here below. Change the signs. Add down. 16 take away 7 would be 9. Okay. Then we want to know how to write our final answer. My final answer is what we have up here at the top. It's known as your quotient. 5x squared. Hey, Zainab. Minus 8x plus 4 plus the remainder, which is 9, over my divisor, which is 3x squared minus x minus 4. You'll have one question like that on your test as well. Okay. Let's go ahead and check out the next one. We're going to do number 5. Number 5 is a review of some synthetic division. Synthetic division is a little bit like long division. If you have any missing terms, then you need to fill them in with zeros, okay? But in this case, that doesn't really matter, because for the problem that we're looking at here on number 5, there are no missing terms. 5, 4, 3, 2, 1, none. So we're good. So it's synthetic division. I know you guys are good with this, but just in case someone wants to practice one, we'll do one here. So we put all the coefficients up here on the top. Then we take this number but change its sign and put it in the front. Bring it down, multiply, add down, multiply, add down, multiply, add down, multiply, add down, and then multiply, add down, and we get, what would that be, negative 11? This is a remainder. This is a constant, an x squared, an x cubed, and an x to the 4th. So my final answer will be 8x to the 4th plus 3x cubed plus 8x squared plus 6x minus 9. I have a remainder of negative 11. And my divisor was originally x plus 1. And don't be surprised if instead of putting a plus here, what they do on your test is they may take this negative and just drop it down where the plus is instead. And there's our final result for that one. All right, moving on. That was number 5. Let's take a look at number 7. You guys are okay. You don't have to be quiet. You're fine. Okay. So if I want to find my possible rational roots, what we do is we're going to make a list of all the factors of my last term. The numbers that divide into 20 are 1, 2, 4, 5, 10, and 20. And then we make a list of all the factors of our first term's coefficient, which are 1, 2, 4, and 8. And basically we make as many fractions out of these as we can. So first of all, if I put all of these over 1, then I'm going to get 1, 2, 4, 5, 10, and 20. These are my possible roots. But then we're also going to do all these numbers. We're going to do all these numbers over 2 now. So 2 over 2 is 1, so I don't need that. But 2 over 4 is a half. We do need that. 2 over 8 is a quarter. We need that one as well. And that's in for that. Then we do 4 over 2, which is 2. We have that. 4 over 4, which is 1. We have that. 4 over 8, which is half. We have that. So we're done there. Then we do 5 over 2, which is 2.5. 5 over 4. And then 5 over 8. I'm running out of space, so I don't really know where to write these, but there's that. Then we have 10 over 2, which is 5, which we already have, so we don't need to worry about that. 10 over 4, which is 5 halves, we have that. 10 over 8, which is 5 fourths, we have that. And finally, for the 20, we'll do 20 over 2, which is 10, 20 over 4, which is 5, 20 over 8, which would be 4, 5 goes in there, 4 over 2. What would that be, 20 over 8? Let me think here. Oh, 5 fourths. We already have that. Okay. And then you keep doing that for all of them. So I'm going to go ahead and just keep working on it, but you guys will get the idea. So 1 fourth we already have. 2 fourths is a half. 4 fourths, 5 fourths, 10 fourths, 20 fourths. We have all those. Let's do the eighths. 1/8. I don't think we have 1/8 yet. 2 eighths we have, 4 eighths we have, 5 eighths. Do we have that yet? Yes, we do. 10 eighths would be 5 fourths, which we have, and 20 eighths we already have that as well. So we're good. We found all of them. And any of these could be positives or negatives.
Sorry.
So there's a lot of possible roots here. Okay, but that's the answer to that one. All right, let's move on. Okay, so let's go ahead and take a look at number 9. So number 9, I'm going to tell you what some of the possible roots are, and your job is to figure out which ones are actual roots. Now, to kind of make this a little bit less tedious, I narrow it down for you to only a few possible roots because it's pretty tedious to have to plug in that many numbers just to find the one that works. So, so for number 9, I'm telling you one of the roots are either -1, 5, or -5, and your job is to figure out which one is the actual root. So let's go ahead and start with -5. So plugging in -5 at first to see if that works. Okay, so -5 to the 3rd power is -125. -5 to the 2nd power is 25. And then we multiply and we get this. But I can tell you right now, just by looking at this, that's not going to come out to be 0. That's what it should be if it's a root, but it's not. So therefore we know that that is not one of our roots. And then we go ahead and just repeat this process for the other numbers until we find the one that makes 0. So let's try +5 now. So this is going to be a +125 times 5, which is 625. This is going to be a +125 now. And this will be -5, and once again, that's not going to make 0. So it's not that either. So that means it must be the -1, or maybe not. Maybe I didn't put anything up there that actually results in a root. But we have to test it to be C. to see. So let's plug in our last one. Negative or positive 5 failed also. Now we're going to plug in negative 1. All right, so negative 1 cubed is negative 1 times 5 is negative 5. Negative 1 squared is 1 times 5 is 5. Those two make positive 5, and then minus 5. And sure enough, there's our 0. So the answer is x equals negative 1 is our root. So that's how you can determine of the possible roots which is the actual root. Okay, let's go ahead and move on to number 11. You guys will like number 11. It's really quick and easy. Just got to remember it. All right, so it says here on number 11, suppose that x equals 4 is a root of some polynomial. If that's true, then what is a factor of that polynomial? The factor theorem says that it will be x minus 4. It's the same, it's just x and then the opposite of this number. So x minus 4 would be the factor. And that's it. Pretty chill. Let's go ahead and move on to number 13. Describe the end behavior of the polynomial given. All right, so when you're looking at end behavior, all you do is you look at the first term. Okay. Now, if you guys want to know what to do, you kind of need to look at the chart that I gave you guys a little while back. So if you look at your 6.5 notes, this is the chart you would see. You have to look at the exponent and the coefficient. So for the problem that we are working on right now, let me get out of here real quick. Number 13, we're looking at 5x to the 4th. So that is a positive coefficient and an even exponent. So what would that be? So we have a positive coefficient and an even exponent. So even exponent, positive coefficient, we have this situation here. Okay, now when you're graphing, it's nice to know what the arrows look like at the ends, but for your multiple choice test, this is what you need to be able to identify. As the graph moves to the left, it goes up to positive infinity. As the graph moves to the right, it goes up to positive infinity. Okay? So that's end behavior. Okay, as for number 15, we're looking for the y-intercept. Plug 0 in for x to find your y-intercept. So if you plug in 0 for x, everything's going to cancel out if it has an x next to it. So in this case, everything does cancel out. They all become 0, and so my y-intercept is 0. But if you ever have just a number at the end, then that would be your y-intercept, because that's what would be left. There's that one. Let's go ahead and move on to number 17. Find the roots of the polynomial which is given in factored form. So I'll give you a question on the test where I ask you to find the roots in factored form, and what you do is you just take each of the factors, set them equal to 0, and solve. So for this first one, we divide both sides by -3 and we get 0. For this one, we get -2. For this one, we get 3. And then for this one, we get -3. So I've got 4 roots there. 0, -2, 3, and -3. Okay, moving on to number 18. Now, which of these roots from question 17 would bounce off of the y-axis? The way you can tell that is by looking at the original problem, and the one that has an exponent that's even is the one that's going to bounce. So x plus 2 has an even exponent of 2, and the root that came from that was here. So this is my bouncing root, and the other ones are through roots. So what that means is that if I were graphing this, which I'm not, but if I were, whenever I graphed this, these would be the 4 points on the x-axis, and what would happen is our graph would go through the x-axis here, here, and here, but it would bounce off of the x-axis at x equals -2. Okay, moving on to, let's see. We did 18. I'm going to skip 19 and 20 because those are repeat questions. Now this is a slightly different question. This one asks us to find the roots as well, but you'll see why it's different in a second. Okay, so first of all, we set each factor equal to 0. Now notice that the directions say this thing is completely factored. Okay, so in other words, you might look at this trinomial and think, uh-oh, I need to do the box on that to factor it. But you can't, because this thing doesn't factor, actually. You could try the box, and I think you'll find that it just doesn't work. So what do we do in that case? Well, let's cross that bridge when we get there. So first of all, we set this one equal to 0. Then we set this one equal to 0. And then we set this one equal to 0 because it doesn't factor anymore, so we just do that. So as for this guy here, we add 4 on both sides. As for this one here, we minus the 5 on both sides. And this one over here, that's a quadratic equation. It can't be factored. The only way to solve a quadratic equation that's equal to 0 is by doing the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay? And then from there we just simplify it up. So I'll work this out real quick. It's going to be 4, negative 4 times 1 times negative 6 is going to be positive 24. That makes 28 on the inside of that root there. We do need to break down our square root. If you don't remember how to break down a square root, I'll demonstrate that for you now. It's 4 times 7. That's 2 times 2. And so we can take out a 2. So here's what we have now. 2 root 7 over 2, which can be reduced. All 3 of these can be divided by 2. So my final root will be negative 1 plus or minus 1 square root of 7 over 1, I mean. But we don't need to write that. So there we go. So we have 4 roots here. We have x equals 4, x equals negative 5, and the quadratic formula gave us 2 other roots. Negative 1 plus the square root of 7, and negative 1 minus the square root of 7. So the purpose of this problem on your study guide was to remind you that yes, sometimes you can get a non-factorable trinomial when you're trying to find the roots. And when that happens, you use the quadratic formula. Okay? All right. Let's go ahead and progress onwards here. That was 21. Let's see what's up with 23. So below you are given 2 things. You're given the equation of a polynomial that is in standard form, and you're given the polynomial that is in factored form, and our job is to graph it. So when it's already in factored form, these problems go by pretty quickly. So we'll have 2 of these on your test probably. So the first thing you're going to do is you're going to find your roots. So this factor would make a root of 0. This factor would make a root of 1. And this factor would make a root of negative 1. And this factor will make a root of negative 3. Okay. The next thing you're going to do is you're going to decide, are they bouncing off of the x-axis, or does the line go through the x-axis? And since this one has an even power, that root will be a bouncing root. The other roots it will go through. The next thing, so that's our roots, right? The next thing we're going to do is we're going to look at our y-intercepts. The y-intercept is what you get when you plug 0 in for x. Now, if you do that, you just get 0. So there's that. Next thing you're going to do, and the last thing you're going to do before you graph, is you're going to determine what your end behavior is. And to do that, you look at your first term. So I've got a negative x to the 5th. And when that happens, it's up on the left and down on the right. So we're ready to graph. My roots are 0, 1, negative 1, and negative 3. My y-intercept is 0, so I don't need to graph that. I've already got it. And then it's up on the left, down on the right, And don't forget to label which one of your roots is a bounce. This one here is a bounce, the -3. So we're going to go down, we're going to bounce, we're going to go through. And there's our graph. That's as precise as we're going to get about it. Okay? Okay, let's move on to, I think, one of our last questions, if I'm not mistaken. All right, number 25. Now, here's another type of question. In this one, I'm not going to give you the factored form, but instead, I'm going to give you a root. And your job is to factor this polynomial completely first. Okay? All right, so step one, we want to factor this. We won't be using this for a little bit. We'll get to that in a minute. But for now, we're just going to start with factoring. So we begin by factoring it, because it's not given to us in factored form. So to factor this, the first thing you want to do is look for a GCF. Now you'll notice that this term doesn't have a coefficient, so you can't divide any numbers out. And this term doesn't have an x, so you can't take any x's out. So there's no GCF. So let's move on. After that, you're either going to do the box or the trinomial, but I'm going to save you the trouble. With this type of question on your test, you're going to, if I give you a root, you're going to have to do synthetic division. So don't even start with the box. Just start with the synthetic division, okay? So, but before we do that, be careful. We're missing a term here. You guys see how we're missing an x squared? So when I put these coefficients in, I'm going to put 1 for the x cubed, but since I don't have an x squared, I'm going to put 0 for that. And then -12 and +16. The root will go out here. Now some of you guys might be confused because you thought, aren't we supposed to change the sign? The answer is no. The reason for that is because this root gives me a factor. The factor is x plus 4. So if you ever have a factor, that's the one that you'll change the sign for here. But if it's a root, you just use the number as is. Okay? And so now we're ready to go ahead and do our synthetic division. So bring down your 1, multiply, add down, multiply, add down, multiply. If you don't get 0, it's time to throw your paper on the ground and get angry because you should have gotten 0 at this point. So we have x plus 4 as a factor from our root. And then we have x squared minus 4x plus 4 from our synthetic division. After you do synthetic division, then you could try to do the box, okay? And in this case, the box will in fact work. So let me work that out really quick. X squared minus, oops.
Water. I'm gonna die.
All right, sorry about our little interruption there. So x squared goes in the top left, 4 goes in the bottom right. And then we look for 2 things that multiply to make x, 2 things that multiply to make 4. And then we need those 2 things to add up to make the middle, which they would if they were both negative. So these are both negative. And so here's what I get this thing to be factored into completely. So now we have x plus 4, and then we have x minus 2 and x minus 2. Now since I have x minus 2 twice, I'm going to rewrite this a little bit. So we have x plus 4, and we have x minus 2 squared. And now after we do all that stuff, all that fun factoring, then we get to do exactly what we did in the problem before this, which is where you're going to find your roots, find your y-intercept, find your end behavior, and then graph it. So this root's -4, this root is 2. Since this one has an even power, it's a bounce. This one does not. It's a through. That's my roots. Next, we're going to do our y-intercept. Y-intercept in this case is 16. In behavior, first term is x cubed. Odd power, positive coefficient, up on the right, down on the left. We're ready to graph. So we're going to go left 4 for a root. We're going to go right 2 for a root. The right 2 is a bouncing root. 4 is a through. My y-intercept is 16. Way up there. My end behavior is down on the left, up on the right, and it's bounce. Oh, I screwed up. Back up. It's bounce, hit the y-intercept, through. And there you go. There'll only be one question like that on the exam because it does take quite a while. So this is how I'm going to ask all these questions on your guys' exam. Basically, for most of the questions, I break it down into little pieces so that each question doesn't take that long, except for this one. This is the one that kind of takes a while. Now, 26 is just like that, but 27 and 28, those are extra credit questions. If you did the extra credit assignments, then you might have a clue on how to do those, and those will also be on the exam if you're interested. And that's pretty much the gist of it, guys. So happy studying. We'll see you Monday.